In this video, we're going to begin to talk about mechanisms for reactions, but first we're just going to talk about the overall theory of how reactions happen, and that's collision theory. And what collision theory says is that, molecules very small, so they're very fast moving and they hit stuff all the time. You're talking about like 100 billion collisions per second for every single molecule there is in a solution. And it's because of these collisions that reactions happen. And it makes a lot of sense if you think about it. Molecules have to be in close contact for a reaction to happen, and so they get in close contact when they hit each other. And so when they hit each other, two things may happen. Two factors really decide if they get in a reaction or not. One, do they hit hard enough that they actually break their bonds, their covalent bonds holding each other together? And when they break these bonds, are they in the correct orientation for new, different bonds to form? And this collision is actually captured in this frequency factor in the Arrhenius equation we talked about last video. So this A tells us, 1, how many times do we collide? And 2, how many times when we collide are we in the correct orientation for a reaction to happen? So that's what that Arrhenius frequency factor is actually telling us. And so let's look at a visual representation of this. So for NoCl2, 2 moles of that will react to form 2 moles of NO and 1 mole of Cl2 gas. So when they collide, they have to collide in a very specific way. They have to collide where both chlorines are facing each other to form Cl2 gas. If they collide any other way, no reaction is going to happen. And so not only do they have to find each other, but both chlorines have to be facing each other when they collide, and that's what's in our Arrhenius factor, our frequency factor. All right. So, like I've said, collision frequency, that's just number of times we have a collision in a second. And the more collisions there are, the more product you'll be forming. Basically, when you raise temperature, right, you're going to raise the number of collisions you have. Orientation factor, on average, or what are the chances when two things collide they're going to be in the right orientation? So most reactions, P is less than 1 because you're not going to be in the right orientation 100% of the time. The only way P is 1 is that if you have spheres colliding, which are just atoms. If you have just atoms colliding, not molecules, the atoms are always in the right orientation because they're spheres, so they collide. And theoretically, you can have reactions that are greater than 1. That's saying, when we look at this inside of a lab or inside of an experiment, the reaction's happening faster than you would predict, and that's usually for reactions that have to do with electron transfer. And we're not really going to go into that topic, though. So the proper orientation is when they collide in such a way that you get a correct molecule. But like I said, most reactions, the orientation factor is less than 1. And that's it for this video. And I'll see you in the next video.